Hello folks, I'll go over today the relative extrema and increasing decreasing intervals for functions, any type of functions. And I have examples for that. So here first, I put this example. It asks us to find the critical numbers and critical points for this function. So just to recall, the critical number is a number c at which f prime of c equals to 0, or f prime of c does not exist. So the second case really happens when you have radicals, and maybe not for rationals, but you may have radicals, but for this one you have the polynomials and exponentials and rationals. So for a polynomial, of course, you set the derivative equal to 0. So find f prime of x, which is 3x squared minus 27, and set that equal to 0. So 3x squared equals to 27. So x squared equals to 9. So x equals minus plus 3. So these are the x coordinates. These are critical numbers. Now for the critical points, you need to set these numbers into, like, you have to plug these numbers into the function, into the original function f. So when you find f of 3, you can use a calculator. That's going to be negative 60. So that gives you the first critical point, 3 comma negative 60. And the second one, if you look at f of negative 3, that's going to be 48. That's going to be negative 3 comma 48. So these two are the critical points. Now let's go to our first example. In this example, we're trying to find the relative extrema and increasing decreasing intervals of this polynomial. So we first need the critical numbers. So let's take the derivative and set it equal to 0. So we got 6x squared minus 6x minus 12, and set that equal to 0. Then you can divide all by 6 to simplify it. So that's going to be x squared minus x minus 2 equals to 0. To find the zeros, you can use a quadratic formula, but actually this polynomial, this quadratic equation can be factored, this quadratic expression can be factored. We look for two factors of negative 2 whose sum is negative 1. So those are negative 2 and 1. You can check that with FOIL. That will give us x minus 2 times x plus 1 equals to 0. So x needs to be 2, or x needs to be negative 1. See, we got the critical numbers now. So we can check the sign of f prime with f prime and then determine the increasing decreasing intervals. So how do we check the sign? Here we go. Let's do it. Let's do that here. So you form this table. This is negative 1. This is 2, and that side is infinity. That side is negative infinity. And here I put f prime, which is 6x squared minus 6x minus 12. You do it like this if you like. So you take a testing value from each interval. Like, choose, for example, from here choose a testing value like negative 2. From here you can choose the testing value 0. From here you can choose 3. Then plug that in f prime. And you just need to check the sign. So I'm looking at f prime of negative 2. So you plug this in f prime. So it's going to be 6 times negative 2 squared minus 6 times negative 2 minus 12. If you look at this 24, it's all going to be positive. You don't really need to, like, you can calculate that easily in a calculator, but you will need to check the sign. If you look at, for example, f prime of 0, that's going to be negative 12. If you look at f prime of positive 2, it's going to be again positive. So we get, once we check the sign, we get plus here, then we got minus here, and then plus here by using the test values. So that means your function is increasing in this interval, decreasing in the second interval, and increasing in the third interval. So you have a max in here, relative max, and you have a relative min in here. So let's just write down now, you plug these numbers into the actual function f. Let's just give some space for us, some space. So I look at f of, if you look at f of -1, you can plug that into the original function. F of -1 will be 19, and you can look at f of 2. F of 2 will be -8. So here we go. We write our conclusion. We just say f. So it's increasing. F is increasing on the interval. If you look at that table, it's gonna be -infinity up to -1 union 2 to infinity, and then decreasing on the interval -1, 2, and then if we look at the relative max and min, you can just say f is a relative max at the point -1, 19, and then f has a relative min at the point 2, -8. So that's one example when you have a polynomial function. So now next continue with another example, which is a radical function, because you can easily write this f as the cube root of x minus 2 squared plus 1. You see, that's a radical function. Now again, we take the derivative for critical numbers, f prime of x. That's going to be 2/3 x minus 2 to the -1/3, because you subtract 1. So you see now, this time you have a negative exponent, which makes this derivative as 2/3 times x minus 2 to the 1/3. See, now this is never 0, because for a fraction to be 0, the top should be 0. But at some point this may not exist, like at 2. So f prime does not exist at x equals to 2. And if you look at f of 2, f of 2 is defined. Like it's 2 minus 2 to the power 2/3, which is simply 0, to the 2/3 plus 1, which is 1. So it exists. The function exists at the value, so it's within the domain. However, the derivative does not exist. So this is the only critical number that we have this time. So see, that's an example in which you have the derivative does not exist. So let's go to the table now. We will do that table, our table. So we have the only point here, 2, side infinity, that side -infinity, and this is the derivative, 2 divided by 3 times x minus 2 to the 1/3. So take some testing values. From here, just take 0, let's say. From here, take 3. And you see, it's so clear. If you plug in, like this is the one that determines the sign. If you plug in 0 in f prime, like f prime of 0, that's going to be 2/3 times 0 minus 2 to the 1/3. You can just check this calculator. This will be negative. and you're taking the cube root of a negative number, it's going to be negative. So that's negative here. And if you look at f prime of 3, that's going to be positive. So it's positive here and then negative here. So it's decreasing and then increasing. So we have a min in here, relative min. So if I write down the increasing intervals, that's 2 comma infinity. Then if I write down the decreasing intervals, it's going to be negative infinity comma 2, and then f has a relative min at the point 2 comma 1. We calculated that before, the value of the function. You can just see that we calculated that in here. It was 1, so I just used that value here. And really, folks, if you take a look at the graph of this function, the graph will look like this. Like in here, really, f prime does not exist here. F prime does not exist because it's like a corner. And at this point, you will have the minimum. You can check the graph. So if you have a graphic calculator, you can confirm all this work. So this was another example, which includes some radical functions. So here's the final example for this video. You try to look at, again, the same problem, relative extrema and decreasing intervals. So let's just first find, and that's a polynomial, so let's first find the derivative. F prime of x equals to 4x to the third minus 8 over 3 times 3x squared. So you see these 3's will cancel. So you got 4x to the third minus 8x squared for f prime. Set that equal to 0. You can factor out an x squared, or you can do more than that, but let's factor out an x squared. You got 4x minus 8 to 0. So x squared equals to 0 gives you only 1 0, which is 0. Or we got 4x minus 8 equals to 0, which gives you 4x equals to 8. So x equals to 2. So now we got 2 critical numbers. So let's check the sign for this function, which is 4x to the third and then minus 8x squared. We got here negative infinity, here you got 0, here we got 2, and here we got infinity. So take some testing values. Let's say this is like negative 1 from here, 1 from here, and then 3 from here. Now plug these in your derivative function f prime. So let's find f prime of negative 1. You can check that easily. So 4 times negative 1 to the third minus 8 times negative 1 squared. That's going to be negative. But it's so interesting. If you check f prime of 1, that's 4 1 to the third minus 4 1 squared, 8 1 squared. That's going to be negative as well. And if you check f prime of 3, that's going to be positive. So you'll get something like negative, negative, and then positive. So which makes this problem a bit interesting. I'll show you the graph. So it's decreasing, and then again decreasing, and then increasing. So it only has a relative min here. And you can definitely take a look at the increasing, decreasing intervals. For increasing intervals, you have only one. It's 2 comma infinity. For decreasing intervals, you can write negative infinity up to 0 union 0 up to 2, or sometimes you just directly write it as negative infinity up to 2. Both ways will work. And then the final part, you only have one relative min. So the final part, you plug in that number 2 into the function, so it's 2 to the 4 minus 8 over 3 times 2 to the third. You can check that. That's going to be negative 16 over 3. The calculator. So f has a relative min at 2 comma negative 16 over 3. Check that with a calculator. And if you look at the graph of this function, the graph looks like this, folks. I mean, it's so interesting. The graph looks like this. It just comes down and then makes like a horizontal tangent line, goes down more and goes up. So here, here there's a horizontal tangent line. This is it. At 0, and here there's a horizontal tangent line. This is at 2, but and here you don't have a relative extrema. So you need to check the sign every time to just see for these type of problems. You need to check the sign, whether that's a maximum or minimum by looking at the sign. But this is the only minimum point that you have. So it's like this is of course 2 comma negative 16 over 3. Okay, so this is the last example for this video. Thanks for watching this video. Bye.